broken legs.
Yeah, that would be, we could look very quickly at slide 92. This is one of the more interesting anomalous events. This was the flash frozen woolly mammoth. Go to slide 93. It's a much clearer. Yeah, this was a mammoth, 6-ton mammoth that was, again, one of these river collapses. The banks collapsed during a warm spring and exposed this remains of a woolly mammoth with soft tissue preserved, contents of the food in its stomach undigested, actually a mouthful of food. The hips of the mammoth were both broken, as if he was thrown back on his haunches very violently. He had an erect penis, which suggests that he was suffocated, which
he was a freak.
Or he was a freak. Yeah, he was.
Cool. Thanks, bro. Thank you, man. Thank you for letting me know.
Laughs at that. That's. The wolves ate the flesh off
I would have
the
been here
skull.
talking to
That's why
myself.
it's
Yo,
buried like that.
Baron,
the
that's
front
sick.
forelimb
The sunglasses
there.
on the G.
Bottom
That looks.
left,
I don't know.
right in the center of the
That
screen,
looks.
that's his back leg.
It just looks like
wow,
it
did
works.
You see right there?
Looks like a character.
The interesting thing about this is,
it looks like fucking.
rapidity of climate change that's implied by being.
You know
able to
that like
freeze a
soft
six-ton
drink
mammoth,
character?
because the contents
know
of his
why.
stomach, according to the studies, had not really been putrefied,
like-
which implies that the entire carcass had been
Cool,
frozen through
not
and through,
cool spot. I mean, okay,
probably
maybe
in
I'm
less
thinking
than
cool
10
spot.
hours.
Well, like Ötzi, the Iceman, that's what happened to him.
That's exactly what happened to him. Yes, interesting point, and that would
I
be
was
a
thinking
subject
that
we should
that
talk about.
milkshake and
Fell in
fries
between a crevice and a
cartoon
glacier,
characters.
correct?
Yeah, it probably got rapidly buried
Forget what they're called.
under the snow and the ice, and that's how he ended up being
overnight.
preserved. Yeah, overnight, exactly. The next slide actually shows a reconstruction of the in a museum in Russia, showing what the mammoth, the circumstances under which he was found. If you go to, let's see.
By the way, as a sidebar on Ötzi, to show you how science changes rather slowly sometimes, it was a decade before they found out he was murdered, because they found arrow point in his scapula here that cut his bone, and he had defensive wounds on his hands and arms, so he'd gotten in a fight, and he had other people's blood on his hands, so he gave as good as he got and lost the fight, so he was murdered.
Wow.
And that took, with all that careful observation and laboratory,
Hey,
it took
Toad.
80 years.
Runs are going great.
Or
You
that
just missed
came out.
Joseph Jr.
Fascinating.
So
stuff.
sometimes this stuff has to just take a while. So if I could try to find some common ground with
It's like
before we sign
the
off,
Pokeroo.
your
You just missed him.
Your book, you have this really great sentence that I quote. It would mean at least that some yet unknown and identified people somewhere in the world had already mastered all the arts and attributes of a high civilization more than 12,000 years ago and sent out emissaries around the world. Okay, I think that's entirely possible cognitively, for sure. What would do it for me would, the boats that they sent the emissaries out on, the wood, the carbon-14 dated, and some specific examples of high arts and attributes of high civilization. So if it's not metal and writing,
Okay, that worked.
whatever it is, I would change my mind. Absolutely.
That's good to hear, Michael. And I think as the
You always miss Joseph, man. He doesn't stay
the last few
on
years,
like he used to. I know.
having been very much
The real
an
Joseph.
outsider, I have felt that the evidence is
Maybe he lurks. It's all
moving
good
in a
if he
direction
lurks.
that is helpful to the argument that I make. I hope it'll continue to be that way. I hope the evidence that you're looking for will come out. But I'm trying to, like I say, my role is a reporter, and I'm trying to be a reporter for the alternative sides of things, but to do so in an effective and hopefully thorough.
There's a good argument
Wonder
in
how
history
he's doing
science
in
to be
Brazil.
made for the role of outsiders.
Yeah,
Complete
really.
outsiders, to come in and shake things up. I mean, Freeman Dyson,
Second
for
candle.
example,
Thanks, man.
you know,
Thanks, buddy.
Totally self-taught, autodidact. I called you an autodidact. Absolutely. And they can make, and if nothing else, they push people to really figure out what it is they believe and why, because otherwise no one's going to challenge them. So,
Marlon Bretz is a good
In
example.
Brazil.
A high school teacher.
right.
Mané.
Randall Carlson. He's a good example.
Well,
of that, too.
Absolutely.
We'll see.
Well,
Do
listen.
you still want to look at this real quick? The
Sure.
Mastodon, I got
Absolutely.
it right here.
Let's do it. He could go for days. That's what I
125.
love about Randall. He never gets tired of this stuff. If you could bottle your enthusiasm, it'd be an awesome pill.
Well, maybe we can talk about that.
Put it in the memory focus there.
Yeah.
All right, we're gonna look at this mastodon here.
125.
125, yeah. So this is a mastodon that was dug up in a pit years ago. Excavation showed that the bones were lying on and in a layer of limey clay or marl, about 1 foot in thickness. When it gets up there, and it goes on to say, the skeleton proved to be badly disturbed and the bones crushed and broken. As an example of the amount of disturbance, one of the ribs lay beneath one of the tusks, while another was thrust through an aperture in the pelvis. A shoulder blade rested to the right of the skull, and one of the large neck vertebrae was found about 10 feet from the skull, near a portion of the pelvis. In spite of the wide dislocation of the parts, now this is where it really is interesting, the bones of one of the feet remained intact and in place, very possibly in the spot where the animal last stepped. So in other words, there was a foot still embedded in the soft material where he was apparently stepping at the time whatever happened to him.
What the fuck, man?
And this is all the same time period as the other mastodon?
We don't have dating on this, but it likely was at the very end, probably right in that Younger Dryas window because of the amount of sediment over it. Go to the next slide, Jamie, and we'll see 126. We can get a better view.
So this thing, theoretically at least, was blown back.
Yeah. Go to, there we go. There you can see one of the femurs that's been busted squarely across. They go on to say that even the largest of the bones, such as the thigh bones, were broken squarely across in places, indicating that some considerable force had been exerted upon them. Any conclusion as to an agency powerful enough to cause such destruction must be highly speculative. So basically what you're seeing here is a mastodon that got smashed into the ground.
Wow.
The forces, there were strong, powerful shear forces that would have literally separated his leg from the foot that's still
He got hit by a huge fart.
into the ground.
Yeah,
So,
really,
there are
maybe.
many examples of this. And the last slide we're going to show. If you go back, this I promise.
You know,
this
I
is-
once went
By a
digging with
giant
Jack Horner,
sloth.
the paleontologist, the dinosaur digger, and he showed these debris flow pileups of dinosaur bones that had been splintered and broken.
Wow.
And these are huge,
Yeah.
just from the force of the water and then piling up at the
Maybe his
the
own
wall.
fart
And so if you could do it to a dinosaur,
Wow.
Right.
propelled
Yeah,
him forward
85.
and broke his foot.
85 is an interesting
His
slide
hoof.
because what it shows is the London Ivory Docks, which over a period of about 2 centuries, this was mammoth ivory that's being dug out of the Siberian permafrost.
That's just a drawing.
Oh, that's just a drawing, yeah. Well,
Megatherium.
That's the problem with that. Like, that's what it looked like.
well, this is what it looked like. A 19th century scene showing the
God, I
ivory
hate
floor
this
of the
fucking
London
back
docks
boost,
covered by
man.
thousands of mammoth tusks.
Yo,
And this went
what's
on
up?
year after
Louis
year after
Cockham's
year
razors
after
is
year
just
for
exactly
roughly 2
this.
centuries.
There is so much of that mammoth ivory,
The
by the way, that
simplest
they use it to make knife handles. I
explanation.
actually have a knife handle that was made out of mammoth ivory. Yeah, and still to this day, not only is it
flatulence
legal, but it's
theory.
common to use mammoth ivory for different kinds of things.
Yeah.
There's so much of it.
well, they're not
Well-
an endangered species because they're
Exactly. Well, it's kind of a loophole.
In this case, though, what we
Arsenal
have is
cars,
tusks that are
radioactive
being,
gas.
again, dug out of the permafrost.
Maybe.
So how did they get there? That becomes the question.
Right.
Does it have anything to do with human predation, or was it a natural catastrophe that somehow ended up putting all these mammoths down and burying them into permafrost? That's the question I
Thanks
want
for being here.
Well, I think we raised a lot of questions. I think we got some pretty good answers. I think we had some great dialogue, and I really appreciate your time, all 3 of you guys. And thank you to Malcolm, and thank you to Mark, and thank you to young Jamie.
well, thanks for hosting.
My pleasure. It was
And
a
thank you
treat.
to you,
It was a
Joe.
treat for
Can I
me.
do a quick shout out?
Yes, shout it out.
I want to thank Brad Young, Cameron Wiltshire, my brother Rowan, my wife Julie for helping all make this possible. I also want to have people go to the Geocosmic Rex website and the Sacred Geometry International website for a lot more of this kind of stuff.
Then I'm going to thank my beloved partner and wife, Santa, who's shared every adventure with me for the last quarter of a century. We've climbed the Great Pyramid together, we've been at the bottom of the ocean together, and I wouldn't be doing any of this
Jeez.
stuff if it weren't for that wonderful woman behind me.
Michael Shermer, who do you want to thank?
Oh, thank my wife Jennifer, my little boy Vinny, and my agent, my lawyer. No. No, but skeptic.com and my partner Pat, who keeps the show running when I'm running around doing things like this.
All right.
And Joe Rogan. Let's thank Joe Rogan, because I can tell you this, Joe. I speak all over the world, and whether it's South Africa, or whether it's Japan, or whether it's Britain, or whether it's the United States, or whether it's Croatia, people come up to me and they say, Joe Rogan said.
Yeah. Oh, well, thank you. I appreciate it. I appreciate
you have the
everybody's
most
listening.
interesting guests. No, you really.
Well, you're one of them, dude. All you guys
Uranium
are. Thank you so much.
fluorine
All right. We'll see you guys soon.
6.
Thank you. Bye.
So long.
6 fluorine atoms around a uranium. Uranium sextafluoride. That sounds like a terrible gas. Oh, what? I thought for sure I blew it up. What? Hexa. Uranium hexafluoride, not sexta? Sexta's what? Isn't sexta 6? Hexa? Sexa? It is a hexagon. It is hexagon. That does... You're right. The hexa does imply structure, which you're right. It has information of structure. Yeah, I just wanted to say the word sex, to be honest. Guys, this is a terrible strat. I hate it. Alright, I'm gonna put another video on.
We're almost at the edge. And I would guess there were 30,000 Kyrenes on the Giza Plateau having picnics. And they just decided they were going to climb the Great Pyramid. Not all 30,000, but several hundred of them. And we just joined them, me and Santha, and we climbed with them. And that actually is one of the moments when I realized
Hidden in our mythic and historical past are
Hello everyone, and thank you for joining us on this special Zoom call. It's a little bit different than what we've done in the past, but
Somewhere
this one's
out
for
there in the
Baron.
solar system, orbiting the sun every 271 days, is an asteroid called 2023 DW that was recently spotted when it came within just 9 million kilometers of Earth. It's a 15-meter diameter rock, about the same size of rock that caused the Tunguska event.
It's an hour long.
NASA said 2023 DW had a 1 in 560 odds of hitting the Earth in 2046, giving us a pretty good chance the rock will miss the Earth entirely. But what would happen if something
real pink
changed its
elephants
orbit
too, bro.
and
Pink
it was
elephants
suddenly
is
on a
fucking
collision
freaking out
course
over
with
this stuff.
Earth? What level of devastation would result from such an asteroid impact if it happened over a city and not in the frozen wasteland of Siberia? Could we deflect or push this asteroid away from Earth before it hits us? Discovered in February this year, the 2023 DW asteroid is currently racing through space at approximately 86,400 kilometers per hour. The odds of the asteroid striking Earth on Valentine's Day 2046, as estimated by scientists, are 1 in 560. But some researchers have put forward different calculations, one of them being a 1 in 400 chance. There's even an estimated area where the space rock might land, marked by the red dots in this image. The potential impact sites extend from a location near the southern tip of India to an area near the eastern coast of the United States. When evaluating the risks posed by near-Earth objects, scientists employ various metrics, including the Torino scale. Typically, potential threats register a score of 0 or below, indicating minimal concern. However, in the case of 2023 DW, NASA assigned it a score of 1 on the 1 to 10 scale, signifying a somewhat elevated level of risk. Over the course of its orbit around the Sun, 2023 DW is expected to make 10 close passes by our planet, with the first one projected to occur on February the 14th, 2046. The asteroid's closest approach during this period will take place on that same day, at a distance of about 0.009614 astronomical units away from Earth. As astronomers continued the risk assessment, the probability of the asteroid colliding with our planet decreased to 1 in 1,584. But what if something goes wrong and scientists' calculations are incorrect? How devastating would the impact be? According to a scientist at NASA's Center for Near-Earth Object Studies, you could compare it to the Tunguska event, which involved an asteroid of similar size exploding in the atmosphere above a sparsely populated region of Siberia in 1908. The power of an airburst caused by a 50-meter wide asteroid, equivalent to a 12-megaton nuclear bomb, could result in a similar catastrophe. If the asteroid 2023 DW were to smash into Earth in the wrong location, it could result in a catastrophic event that would destroy a city. The Tunguska event explosion covered an area approximately 2,000 square kilometers. More than 80 million trees were flattened, and a huge number of trees and bushes were burnt to cinders in the explosion area. Eyewitnesses described seeing a fireball as bright as the sun. Seismic and pressure waves were recorded in many observatories throughout the world, and bright lights in the sky at night were observed over much of Eurasia. Just imagine this kind of explosion over a populated city. So what can we do in case of a genuine threat? NASA and the European Space Agency have been actively exploring ways to deflect potentially hazardous asteroids. In a recent test, NASA's Double Asteroid Redirection Test spacecraft demonstrated that it could alter the orbit of an asteroid by deliberately colliding with it. Following this successful test, the ESA is planning a similar mission called HERA. ESA's HERA spacecraft is set to launch in October 2024 and is tasked with performing a detailed survey of the binary asteroid system known as Didymos, specifically its moonlet Dimorphos, which was impacted by NASA's DART mission. HERA will be equipped with advanced technology, including automated guidance and control, to navigate the asteroid system safely and survey the crater left by DART. It will also measure Dimorphos's mass and composition using a set of instruments including an asteroid framing camera, thermal and spectral images, and a laser altimeter for surface mapping. HERA will also deploy a pair of shoebox-sized CubeSats to the vicinity of Dimorphos. As the first spacecraft to rendezvous with the binary asteroid system, HERA is Europe's flagship planetary defender that could be used in future asteroid deflection missions. By the time 2023 DW makes its closest approach to Earth in 2046, space agencies and policymakers will have a better understanding of how to deal with a potential impact threat. The success of the DART mission provides hope that if necessary, the orbit of a threatening asteroid could be altered to avoid a collision with our planet. None of these plans, however, will be put into priority unless the odds of an impact go higher than 1 in 100. But what if we face an asteroid that's immune to our strikes? Recent research on the Itokawa asteroid suggests that some asteroids may be far tougher than previously assumed. Scientists believe that it may have formed over 4.2 billion years ago from the shattered remains of a monolithic asteroid. Porous rubble pile asteroids, or half-empty collections of loose boulders, are surprisingly durable. Examining the dust particles from Itokawa, scientists have found that the asteroid has survived catastrophic collisions for almost the entire history of the solar system. And this is a big problem for current deflection strategies aimed at transferring the momentum of kinetic impacts as porosity decreases the efficiency of such impacts. However, the study also suggests there may be more aggressive approaches. One of them is nuclear blast deflection, which would have a much higher chance of success against these porous asteroids. We might need to develop new mitigation strategies to prevent asteroid collisions with Earth, because who knows how many more surprising qualities space rocks may still hide. The ongoing exploration of asteroids by missions like Hayabusa and OSIRIS-REx is expanding our knowledge of these cosmic rocks and their potential impact threat. Starting in 2024, the Vera Rubin Observatory will conduct a broad survey of the sky. Scientists expect to detect thousands of asteroids that could pose a threat to Earth. Meanwhile, NASA's NEO Surveyor mission, set to launch in 2028, will significantly increase the number of known asteroids. Scientists are also developing a new way to track asteroids more accurately using a cloud-based data analysis technique. This will help distinguish between near misses and real threats, making it easier to prevent future asteroid impacts. As technology advances and we continue to explore the cosmos, we're constantly discovering new asteroids that could potentially pose a threat to our planet. In the coming years, there could be even more hazardous objects lurking out there, waiting to be discovered. There are millions of asteroids floating in our solar system. Every year, thousands of meteorites weighing about a pound fall on Earth. Usually we don't see them because they land in uninhabited forests or the ocean. However, in 2004, scientists discovered a really dangerous asteroid in space, weighing more than 20 million tons. The first observations show it has a 2.7 chance of hitting us in 2029. If an asteroid this big hit the Earth, it would cause major devastation over the area it impacted. But what is the real chance of it hitting us? And what can we do to prevent big asteroids from hitting our planet in the future? Apophis was first discovered on June 19, 2004 by astronomers in Tucson, Arizona. The asteroid measures about 1,100 feet across, about the size of 3.5 American football fields. It raised alarms because initial calculations had shown there was a good possibility it could smack into the Earth April 13, 2029. Since its discovery, optical and radar telescopes have been tracking Apophis as it orbits the Sun, and scientists are mostly confident they know where it's headed. Current calculations show it will come really close to the Earth at around 19,800 miles from our planet's surface in 2029. That's close enough to come between the Earth and the Moon, which floats around us at about 238,855 miles away. The path the big asteroid is taking is within the distance of some satellites, and that sounds too close. But what if something affected the orbit path of Apophis, which is very possible, and this asteroid smashed into our planet? It's a well-known fact that an asteroid impact is one of the things that can cause global mass extinction, especially if this asteroid is large enough. Physicists like the late great Dr. Stephen Hawking said that an asteroid collision is the biggest threat to all life on the planet. If an asteroid like Apophis was to hit the Earth, the impact would unleash a blast equivalent to over 1 billion tons of TNT. In comparison, the recent explosion in Lebanon, Beirut, of approximately 2,750 tons of ammonium nitrate caused an explosion equivalent to 1 kiloton of TNT and took the lives of over 200 people. Thus, an asteroid impact by Apophis directly over a populated area would not only result in the deaths of millions of people, but would also have a terrifying and lasting impact on the ecosystem of our planet. Although it may not be an extinction-level event, it would forever change our biosphere and affect human civilization for centuries to come. Asteroids were crucial in the formation of planets in our solar system. Major impact events have significantly shaped our Earth's history and have been associated with the formation of the Earth-Moon system, the evolutionary history of life on our planet, the origin of water, and several mass extinctions. On other planets in the solar system, asteroid impacts have resulted in various phenomena. The two distinctly different hemispheres on Mars are because of asteroid impacts some 3.9 billion years ago, and the unusual spin of Uranus was confirmed to be caused by a collision with a massive object twice the size of Earth. It's very rare for an asteroid the size of Apophis to pass so close to Earth, although smaller asteroids in the range of 16 to 33 feet in size have been observed passing by at similar distances. These type of asteroids are classed as near-Earth objects, or NEOs, and these objects and their orbits are constantly tracked by astronomers around the world. NASA uses Earth Impact Monitoring System to automatically track and scan asteroids that will probably hit us within the next 100 years.
We was bow back
become an
and
increased
shit.
interest since 1994, when big pieces of the Shoemaker-Levy 9 comet slammed into Jupiter after being torn up by its gravity. Scientists got to see it in real time as Earth telescopes were recording it. This event highlighted the potential danger of NEOs. As of January 2019, 19,470 NEOs have been discovered.
They were aliens.
Only 107 of them are comets that are largely made up of ice and rock, while 19,363 of them are asteroids. These asteroids are classified into different categories based on their orbits and the danger they pose to Earth. So far, there are 4 orbit classifications. Amor class are types of asteroids whose orbits do not cross Earth's orbit around the Sun, thus posing no threat to us. The Apollo class of asteroids are Earth-crossing, whose orbits are greater than that of the Earth. Their perihelion, which is the nearest point to the Earth, is less than 1.017 astronomical units. 1 AU is roughly the distance between the Earth and the Sun, 150 million kilometers or 92.9 million
Yes,
miles.
I'm half Lebanese.
The 2013 Chelyabinsk meteor that exploded over the city of Chelyabinsk in the southern Urals region of Russia
I'm
was an
half
Apollo-class
Scottish.
asteroid.
I'm actually quarter
As
Irish,
of
quarter
December
Scottish.
2018, the number of known
and
Apollo
half
asteroids
Lebanese.
is 10,485, making the class the largest group of near-Earth objects.
So we
Atten's
built
class of asteroids
Stonehenge
are Earth-crossing and are a dynamic
Baalbek.
group of asteroids whose orbits bring them into close proximity with Earth. Their orbits are smaller than the Earth's orbit
Like
around the
Burger
Sun,
King
or
Trail.
less than 1 AU. This makes them potentially hazardous objects, or PHOs. As of 2019, 1,490 Attens have been discovered, of which 12 are named. Apophis is an Atens-class asteroid that completes an orbit around the Sun in a bit less than 1 Earth year. After its close encounter with the Earth in 2029, the orbit of Apophis will be widened to become slightly larger than the width of Earth's orbit. At this point, it'll be reclassified from the Aten group to the Apollo group. Finally, there is the Atira class of asteroids, whose orbits are strictly inside the Earth's orbit and are no immediate threat as of now. However, their orbits can be altered because of the gravitational effects of the inner planets of our solar system like Mercury and Venus, which could make these Earth orbit-crossing asteroids in the future. Based on these classifications, scientists have also come up with scales to measure the impact hazards of asteroids. Scientists now believe that there is no danger of Apophis hitting us in April 2029. But space by its nature is unpredictable. And despite our best efforts, if tomorrow scientists discover an asteroid heading towards us, given our current technologies, there's really very little we can do. The only thing that will help us is time. The earlier we spot such objects, the more our chances of survival increases. Today, it's estimated that it would require us to have over a decade of planning to significantly alter the path of an asteroid's trajectory, or to minimize the effects of a potential impact. That's why searching for NEOs and tracking them have become such an important mission for space agencies around the world. This lack of human capability has also given rise to a new field of study known as asteroid impact avoidance. In recent years, many agencies around the globe have concentrated resources and funding towards future missions that aim to change an asteroid's trajectory. Since then, many scientists and engineers have proposed various ways to attempt this. Some have suggested we strap rocket engines to the rock that threatens us and push it away. Others have suggested that we use nuclear weapons to kick an asteroid from its orbit, or even shatter it into smaller bits. These ideas have led to ongoing missions such as the Double Asteroid Redirection Test, or DART, which is a collaboration between NASA and ESA to test the hypotheses of impacting a spacecraft into an asteroid to bring about a change in its trajectory. These days, scientists study asteroids' trajectory, size, shape, composition, and even their interior. All this research will provide humanity with the required knowledge to develop impact avoidance technology. Apophis flying so close to the surface of Earth in 2029 is such an incredible opportunity for science. The asteroid will be in range to be observed with both optical and radar telescopes. Radar observations could
They're using
possibly
massive
provide
magnets
surface details that are only a few
to
feet
draw
in
in
size.
the asteroids
There are
because they
currently many
want
missions
the
being
metal
planned
ore.
to make full use of this rare opportunity. That being said, there is still a small probability
Can you
that
imagine that's the
Apophis
end of
has
the
a
world
chance of
as a
impacting
massive
Earth.
magnet?
In its
People,
close encounter
capitalism
with
literally
Earth, Apophis
draws
would
this
pass through a
massive
gravitational
iron
keyhole,
rock.
a small region no more than about a half a mile, 0.8
Destroys
kilometers
Earth.
in diameter, that could set up a future impact exactly 7 years later in 2036. But the chances of that are said to be less than 1 in 100,000. This gives the asteroid an impact hazard of level 1 on the Torino scale. So despite its close approach, you'll not have to spend sleepless nights wondering whether it'll hit Earth or not.
Like it's impossible.
In August of 2013, scientists launched a project to map a
Across
portion
the
of the southern
universe?
sky, which completed in
What?
2019. It's called the Dark Energy Survey. An incredible 570
In a vacuum,
megapixel
like in
camera
space?
called the Dark Energy Camera grabbed data from over 300 million galaxies amounting to 50 million megabytes. Scientists
I
have
did not
just
know that.
begun to go over that data, and they found something that they didn't expect. Data created 32 images showing a blurry dot in the darkness of space, located about 2.5 billion miles away from Earth. It wasn't until it got close to the planet Uranus that astronomers were finally able to figure out what this strange object was. What scientists detected was a comet with a size 1,000 times above average.
Man.
It was dubbed
too dumb,
C2014
guys.
UN271,
This
also
is too
known
tragic.
as Bernstein, after its discoverers. Given the amount of sunlight it reflects, astronomers speculate the object's diameter is somewhere in between 60 to 125 miles. That's an insanely big number. To compare, an asteroid that wiped dinosaurs out of existence is thought to have been just around 6 to 9 miles wide. But since Bernardinelli Bernstein is still so far away, it's not clear whether the calculations are close to real measurements. Another fascinating fact about this comet is that
What
the
the
last time it
fuck?
entered our solar system was 3 million years ago.
man?
That's about the same time a well-known human ancestor, Lucy, lived. Given such a long orbital period, it seems the comet should have come from a very distant place. And it happens
thought I
there's
thought it
just
was
such
in
a
left
place,
strafe.
believed to be
I was
home
like,
to
I was really
trillions of
dumb of me.
comets. It's a place called Oort Cloud, a spherically shaped region of space containing various remnants from the early ages of our solar system. The Oort Cloud is located far beyond the dwarf planet Pluto and might stretch to 10,000 AU from our star.
Interesting.
So
Hi,
scientists think Bernardinelli Bernstein is the most remote comet we've successfully spotted on its way to us. Such an early discovery gives us plenty of time to study this comet and eventually explain its nature. So when will it get close to us? According to scientific estimates, the closest encounter with the Bernardinelli Bernstein comet will come in 2031. So far, astronomers claim the comet imposes no threat, as it will fly by at a significant distance from us. The closest it will get is 11 astronomical units. That's about 10 times farther away from the Sun than the Earth. It won't even be visible in the sky with the naked eye. But since comets' behavior is hardly predictable, we don't know what to expect. Unlike Bernardinelli Bernstein, certain celestial objects will get much closer to us, and a lot sooner. One of such space guests is a killer asteroid that will fly by within less than 0.07 AU. In just about a year, a binary asteroid named Didymos, accompanied by the smaller Didymoon, will make a near-Earth approach. The bigger asteroid is roughly 780 meters in diameter, while the smaller one is just about 160 meters. However, that's more than enough to make a crater that's 6 miles
Push me,
wide
come on.
and demolish entire cities.
Like, come on.
Even space rocks that are 500 feet wide are capable of exploding with the energy equal to a
This is
nuclear
so
bomb.
fucking dumb,
A
guys.
meteor, a tiny piece of an asteroid or a comet that exploded over Chelyabinsk, Russia, created a massive
did it come?
shockwave. As a result, tons of buildings were damaged and roughly 1,500 people were injured. And it was only about 65 feet wide. But data concerning asteroid impacts has become even more disturbing. NASA has recently conducted an experiment that proved we wouldn't be able to do anything about an asteroid heading straight towards us, even if we had 6 months warning. The simulation of the hypothetical scenario involved an asteroid at a distance of 35 million miles. Throughout each phase of the exercise that lasted a week, scientists received more and more data about the asteroid. They found out about the object's course, odds of hitting our planet, and its size, but they couldn't come up with a working solution to deflect it. Turns out we haven't yet invented spacecraft that could eliminate such a threat within 6 months. In fact, such a mission would take us 5 to 10 years. In the simulation, the asteroid would have landed on Eastern Europe. In fact, the only way to escape the big rock was to evacuate the impact area. And that's not helping us too much. But as we know, some things that don't work out in theory can show us good results in practice. So now, NASA plans to smash a spacecraft about the size of a refrigerator into the smaller Didymoon asteroid that was mentioned earlier. The mission is called Double Asteroid Redirection Test, or DART. The idea is to take this half-ton spacecraft and crash it into Didymoon around 4 miles per second. The launch will take place sometime between November the 24th, 2021 and February 15th,
Alright, be right back.
2022. However, the collision should happen between September and October 2022. This is going to be the very first test using the kinetic impactor technique to alter an asteroid's trajectory and speed. and will be a kind of military training in terms of space. Now, Didymos doesn't threaten Earth yet, but NASA's database contains more than 2,000 potentially hazardous asteroids that can get as close to us as 0.05 astronomical units. Asteroids and comets are often hard to detect, even with the most advanced technology. But at times, people equipped with homemade telescopes make huge discoveries. Just 2 years ago, an amateur astronomer named Gennady Borisov stumbled across a celestial object with a peculiar trajectory. Turns out he found a comet, and not an ordinary one either. It was later discovered by scientists that 2I Borisov is a rogue comet. This is because this type of comet has no steady orbit and will freely float through space until affected by another celestial object. As astronomers continued to study 2I Borisov, they used NASA's Hubble Space Telescope and Atacama Large Millimeter Array, ALMA, to figure out the comet's extraordinary composition. It had an abundance of carbon monoxide they didn't expect to see, and knowing about this high concentration of carbon monoxide, scientists made assumptions about its origin. So far, astronomers have come to the conclusion it should have been created in a place overflowing with CO ice. Such an abundance of CO ice is only present in space regions with a temperature below -420 degrees Fahrenheit. There are two theories about how the comet formed. It could have been born around a red dwarf, a relatively small star with a low surface temperature. Otherwise, it could be a tiny fragment of a dwarf planet. This has become the first comet that entered our solar system from a place outside of our star's influence. But this is not the only thing that captured astronomers' attention. When approaching a star, a comet's particles start to melt and generate a fuzzy cloud around its nucleus. This cloud is called a coma. So what scientists noticed was a unique polarization in Borisov's dust grains. Now, polarization is the direction light waves ripple in space. The higher the polarization, the more focused the light is in a single direction. That's exactly what 2I Borisov's coma demonstrated. In the scientific community, this was a big deal. Similar to the way our skin reacts to direct sunlight, the more a comet interacts with a star, the bigger the impact on its materials. Eventually, the polarization of the comet's coma gets reduced. But what we see with Borisov's comet is quite the opposite. This can only mean one thing. It is rarely or never bathed in a star's light, radiation, or winds. So it's one of the most untouched and well-preserved comets we've ever detected. This leads us to the conclusion that the comet contains unaltered information about the materials that formed it in the first place, which could have happened some thousands, millions, or even billions of years ago. And since astronomers believe the birthplace of 2I Borisov partially resembles our solar system, that comet can reveal valuable information about another solar system much like ours. Borisov's comet already traveled past our sun in 2019. But this doesn't mean there aren't any other celestial objects about to visit us. We can only hope our telescopes will look in the right direction and at the right time, so that we can prepare ourselves once they show up. There are thousands of space rocks of all different sizes floating around in our inner solar system, and many of them are moving on a path towards us. These objects are called asteroids, and recently NASA has made some startling discoveries. You may have heard the news that an asteroid is hurtling towards the Earth, and you may have also heard that it's scheduled to wipe us out on November the 2nd, 2020. So, should we really be afraid of an asteroid impact? And if yes, what should we expect? Will humanity finally find a way to destroy huge, dangerous asteroids before one wipes us out? The asteroid we're talking about was discovered in 2018
Full moon
by the
tonight.
Zwicky Transient Facility, which is an incredibly giant telescope in Palomar, California. NASA is calling it the 2018 VP1 asteroid, and it's about the size of a car. As asteroids are concerned, it's not huge, but the fact is, it's heading straight for us. If you take a look at Earth's orbit and the trajectory of 2018 VP1, you can see that it's coming awfully close to the planet. But there are some problems when it comes to knowing if an asteroid is going to smash into us or not. That's because it's hard to track the path of asteroids out there in space and predict where they're going to go. This is because some of them are too small and dull. In fact, even though 2018 VP1 was spotted a couple of years ago, NASA lost track of it and didn't know where
I
it was.
might sign off
Even
soon,
with
my
advanced
friends.
telescopes and dedicated observations,
Honestly, I might
it's still
sign off
very hard
soon.
to understand where an asteroid is going to go. There are many things that can change the path of an asteroid. It can change path just from the heat of the sun, or another nearby wandering space debris, or even a planet can alter the course of an asteroid that could send it on a collision course with Earth. Asteroids hitting Earth really got people's attention after the recent Chelyabinsk meteor incident in 2013. This chunk of space rock was approximately 66 feet in diameter and entered the Earth's atmosphere over the southern Ural region of Russia at a speed of approximately 42,900 miles per hour. Although the asteroid disintegrated before hitting the surface of the Earth due to the intense heat produced by its entry, it still caused a fireball which was brighter than the sun and was visible up to 60 miles away. Some eyewitnesses also felt intense heat from the fireball. And then on August 22nd, 2020, it was claimed by NASA that an asteroid was headed towards Earth and would enter the atmosphere on November the 2nd, a day before the US presidential election. What immediately followed was shock headlines and social media posts sensationalizing the announcement, and because 2020 had already served up devastating bushfires, hurricanes, and a global pandemic, many people have become legitimately scared that even more devastation was headed our way. But it would seem for now that there is nothing to worry about, because asteroid 2018 VP1 is unlikely to hit Earth and should pose no threat to humanity. This asteroid was discovered by NASA back in 2018 while it was 280,000 miles away from Earth. It's estimated to come within 2,796.17 miles of Earth on November the 2nd. That's really close in space terms. There's a slight chance, about 1 in 240 or 0.41%, the asteroid will hit the Earth. However, the asteroid is so small that even if it enters our atmosphere, it's likely to disintegrate into a fireball and break up into a million pieces before reaching the surface. This recent scare caused by this close flyby shows it's the right time to analyze the effect asteroids have on our planet. Since the beginning of recorded history, there have been multiple records of asteroids impacting the Earth. Slightly over 65 million
no
years
idea
ago,
what you
an
guys are
asteroid,
talking about.
now known as the Chicxulub meteor, which had the diameter of between 10 to 50 miles wide, slammed into the Gulf of Mexico and started an extinction event that wiped out nearly 75% of all life on Earth and is credited with the extinction of the dinosaurs. Elsewhere, mammoth craters of blasted out Earth have been discovered from the continental United States all the way to Russia, such as Barringar Crater in North America, Gossis Bluff in Australia, and Lake Bosumtwi in Africa. In reality, the chances of that happening within our lifetimes are fairly small. Our solar system has an entire region between the orbits of Mars and Jupiter known as the asteroid belt. This belt is estimated to contain between 1.1 and 1.9 million asteroids larger than half a mile in diameter, and millions of smaller ones. Between 1988 and 2017, NASA counted over 700 fireballs created by different sizes of space rocks entering our atmosphere. In order to detect asteroids, NASA takes multiple pictures of the night sky and uses computer programs to scan for moving objects. These observations are made from multiple locations all over Earth, and as the planet rotates, several observations are made that keep track of the orbits of all asteroids and determine how close they are to Earth. The nearest asteroids are called near-Earth objects, or NEOs, meaning they orbit at roughly a third of the distance from the Sun. There are over 20,000 NEOs that are known and are currently being tracked. Based on the object's speed and brightness, scientists can map a trajectory to predict whether it will collide with Earth. If an NEO's orbit crosses the Earth's and the object is larger than 450 feet across, it's considered a potentially hazardous object, or PHOs. The impact energy of a 30-foot diameter asteroid is projected to be around 100 kilotons, but the larger the object, the deadlier the impact. A PHO with a diameter of around 500 foot, just a little larger than the Great Pyramid of Giza,
Probably 5
has
more
the
minutes
potential
on
of
the sign
generating
off. Thanks for
approximately
being here,
300
everybody. Really
megatons
appreciate
of
it.
energy on impact. For reference, the number of megatons that was produced by the explosion of the most powerful nuclear weapon ever created and tested, the Tsar bomber, was only 50. This kind of asteroid strike could have the potential to cause millions of deaths and the destruction of entire cities. But the most worrisome thing is that asteroids don't always have to impact the surface of the Earth to cause damage and destruction. The Chelyabinsk meteor mentioned earlier dealt a lot of damage despite not hitting the ground. The blast created by the asteroid's airburst produced extensive ground damage over an irregular elliptical area around 60 miles wide and a few tens of miles long, with the secondary effects of the blast being the main cause of the considerable number of injuries. Russian authorities stated that 1,491 people needed medical attention in Chelyabinsk Oblast within the first few days, and over 7,200 buildings were damaged with collapsed roofs and shattered windows. That's why many nations around the world are scanning the sky for NEOs in an effort called Space Guard. The initial goal of the mission, to catalogue at least 90% of NEOs that are at least half a mile in diameter and could cause a global catastrophe, was met by 2011. Now the survey has been expanded to catalogue and track smaller objects which have the potential for large-scale, though not global, damage. For now, we are safe. But what if we spot a large asteroid coming towards us? What actions could we take? Our ability to prevent a devastating asteroid impact depends on how big the asteroid is and, most importantly, when we detect it. For example, a PHO on a path to collide with Earth, if detected 1 year out, is almost certainly going to impact us. The only thing to do would be to evacuate the impact zone.
No worries.
However, if it was detected 7 to 8 years out, then we would have a real chance to deflect the object. Currently, scientists have proposed various ways of doing this. The first method proposed is to detonate a nuclear device on the surface of the asteroid, or near it, so that the blast either breaks up the asteroid or pushes it onto a different trajectory. If the asteroid is far enough away, it'll only need to be pushed a few inches to bring enough change in its trajectory to miss Earth. Despite the risks of fracturing the asteroid and the unpredictability of debris after such explosions, this method of impact avoidance is still the most serious contender and has resulted in the creation of a conceptual Hypervelocity Asteroid Intercept Vehicle, or HAIV, which combines a kinetic impactor to create an initial crater for a follow-up subsurface nuclear detonation within that initial crater. The second, less drastic method to come out is the kinetic impact method, which literally uses a spacecraft as a battering ram to change the trajectory of the asteroid in question. This method has received major support from NASA in the form of the Double Asteroid Redirection Test, or DART mission, which is currently in its
and then you would have nuclear asteroids coming
out
at
the target
us.
asteroid in the second half of 2021. The DART space probe's target is a PHO-sized asteroid called Dimorphos, located in the Didymos binary asteroid system. The idea is to impact the asteroid at a substantial velocity to initiate a trajectory change. The Didymos asteroid system is not in any Earth-crossing trajectory, so there is no possibility that the deflection experiment could create an impact hazard. If successful, this mission will be the first ever proof of concept towards asteroid impact avoidance. Other concepts include ideas such as the asteroid gravity tractor, where a spacecraft orbiting near an asteroid is theoretically enough to bring about a slight change in its trajectory due to the spacecraft's gravitational pull and the size and mass of the spacecraft. This system can, over time, redirect the asteroid, pulling it away from the Earth. Then there are proposed concepts such as focused solar energy and asteroid laser ablation, both using directed energy to cause jets of material heated by the solar energy or high-powered laser to fly off the surface of the asteroid, and that is essentially the equivalent of a jet engine pushing the asteroid off course. All these ideas are fundamentally strong, but need to be tested one by one to prove their effectiveness, and this will take time. So far, scientists and astronomers have not yet found any objects big enough or on course to threaten the Earth.
May you achieve your dream, Hideyoshi.
For that long. There are still huge swathes of space to be surveyed and new technologies to be developed. It might be that a huge asteroid somewhere out there in the vastness of space is probably on its way towards us, and we just haven't found it yet. Our solar system began as a disk of dust and gas some 4.6 billion years ago. The first planets to form were the gas giants Neptune, Uranus, Saturn, and Jupiter. Jupiter took shape about the same time as the rest of the solar system, forming around 4.5 billion years ago. its strong gravity pulling in massive amounts of gas and dust from the disk before all the other planets formed. It was the first and the largest. Jupiter is mostly made up of hydrogen and helium, about 90% hydrogen and about 10% helium, almost the same composition as our Sun, which is about 70% hydrogen and 28% helium. Some astronomers call Jupiter a failed star. However, the gas giant only has a mass of 1/1000th that of the Sun. Jupiter just isn't massive enough for gravity to trigger nuclear fusion. The beautiful whirling clouds and storms that you see in images, the layer resting on the surface known as the troposphere, are about 31 miles thick and are made up of ammonia, ammonium hydrosulfide, and water, which form the distinctive red and white bands. When you look at Jupiter, you probably think that it must have a solid surface. The fact is that Jupiter doesn't have a true surface. It's mostly swirling gases and liquids, and if you sent a spacecraft there, it would have nowhere to land. But just because the spacecraft wouldn't have a place to land doesn't mean it would fly right through Jupiter's atmosphere and come out unharmed through the other side. This is because extreme pressures and temperatures deep inside the planet would crush, melt, and vaporize any spacecraft trying to fly into the planet. But we've sent spacecraft to orbit and explore the planet. The $1 billion Juno probe, the farthest space probe ever to be powered by solar arrays, was launched towards Jupiter on August 5th, 2011, and arrived in orbit around the planet on July 4th, 2016. And what we've discovered and learned about Jupiter is incredible. The newest discovery using data collected from the Juno spacecraft found that the colourful stripes of swirling gas and dust you see in Jupiter's atmosphere were found to run 1,800 miles deep and hold so much gas that the mass is about 3 times that of the entire Earth. These belts of wind flow at speeds of 223 miles per hour and disrupt how mass is spread across the planet. It was also discovered that Jupiter's atmosphere is rotating differently, with zones and bands rotating at speeds that are different by up to 328 feet per second. Those bands on different colors you see are actually traveling in opposite directions. Lighter bands move in the direction